we need to evaluate each of the following. Beginning with the first one, we need to find out the value of square root of 843.6, and it's given that log of 84.36 equals 1.9261. Okay, first we will assume that x equals to the square root of 843.6. Now we're going to square both sides. So squaring both sides gives x squared equals to 843.6. Now we're going to rewrite 843.6 as 84.36. That means we need to multiply it with 10. Now what we'll do, we'll take the logarithm on both sides to get logarithm of x squared equals to logarithm of 84.36 times 10. Now we can apply the property of logarithm. So logarithm of x squared is going to be 2 times log of x. That's going to be equals to log of 84.36 added to log of 10. Now here each of the logarithm has a base 10. All of them has got the base 10, which means that log of 10 with a base of 10, that's going to be equals to 1. Now we have 2 times log of x with a base 10, that's equals to log of 84.36, and it's given that that's 1.9261. 1.9261 added to log of 10 with a base of 10, that's always going to be 1 by definition. This means that 2 times log of x, that's going to be equals to 2.9261. Now we're going to divide both sides with 2. So log of x is going to be 1.46305. Now we have to obtain the value of x, because x is going to be square root of 843.6. Using the definition, so here since the base is 10, we can use the definition. That means log of a to the base of b, if it's equals to c, this simply means that a will be equals to b raised to the power of c, which means in our case we have x was going to be equals to 10 raised to the power of 1.46305. Now we can use a calculator to compute the value for x. So x comes out to be approximately 29.04. In other words, we are saying that square root of 843.6 comes out to be 29.04. Let's move on to the second problem. So here we need to obtain the value of the fourth root of 0.038. Let us begin. So we'll consider y to be equals to the fourth root of 0.038. So in order to get rid of the fourth root on the right hand side, we can take raise the power to 4 on both sides. Instead we get y raised to the power of 4 equals to 0.038. Now we can express 0.038 as 38 times 10 raised to the power of -3. Now we're going to take the logarithm on both sides. The logarithm with a base 10, the logarithm of y raised to the power of 4 is going to be equals to logarithm of 38 times 10 raised to the power of -3. Now using the properties of logarithm, we have 4 times log of y, that's going to be equals to log of 38 added to log of 10 raised to the power of -3. This is going to be 4 times log of y equals to log of 38, that's 1.5798. The log of 10 raised to the power of -3 is simply -3 log of 10. Now log of 10, that's 1. This is now going to give us 4 times log of y equals to 1.5798 minus 3, which will be minus 1.4202. Now we will be dividing both sides with 4 such that we get log of y equals to minus 0.35505. Now in order to find out y, actually here we have to take the anti-logarithm of -0.35505. But what we'll do, instead of taking the anti-logarithm, what we'll do, we know that the base is 10. So that means y is going to correspond to 10 raised to the power of -0.35505. We can use this value, we can compute this value, then y comes out to be equals 0.4415 5. And we can verify that if we take the fourth root of 0.038, that also comes out to be approximately 0.4415. Now let's go to the final problem. So here we need to compute the sixth power of 0.849. So let's suppose that z corresponds to the sixth root of 0.849. So to get rid of the sixth root, we're going to raise both sides with the power of 6. That's the z raised to the power of 6 going to be equals to 0.849. However, the expression on the right hand side, that's 0.849, we'll be writing in terms of 84.9. That means we need to multiply with 10 raised to the power of -2. Let's apply the logarithm on both sides. We have logarithm of z raised to the power of 6 equals to the logarithm of 84.9 times 10 raised to the power of -2. Applying the properties of logarithm, we have 6 times log of z equals to log of 84.9 minus 2. This will be 6 times log of z equals to the log of 84.9. That's value is given to us. That's 1.9289 minus 2. That will be equals to 6 times log of 2 equals to minus 0.0701. Next, what we'll do, we'll divide both sides with 6 to get log of z to be equals to, as is log of z, that will be equals to negative 0.0701 divided by 6. So we have log of z equals to minus 0.01185. That's going to be the value of log of z, and to find out the value of z, we have to take the anti-logarithm. In other words, we have to find out z. So z comes out to be the anti-log of negative 0.01185. Now, to find out the anti-log of this number, we have to use a table. But what we'll do, we're not going to take this approach. Instead, we're going to use the definition. Since the base is 10, that means z will be equals to 10 raised to the power of negative 0.01185. We can compute this value with the help of a calculator. So that's going to give us 0.973. So this is going to be the sixth root of 0.849. We can verify that by using a calculator, that the sixth root of 0.849 also comes out to be a value which is very much close to 0.973.